No.
It's Wi-Fi. Please.
Thank you.
Thank you.
Hello. Okay. Can you hear me? The one in the back. Yes. Thank you for ESO meeting organizers to give me a chance to introduce our ePESSTO Plus project to all of you. And my name is Ting-Wan Chen. You can just call me Janet. I recently moved to Taiwan to the National Central University. And then in my final slide, I will show you an invitation. Welcome to come to Taiwan. But today, I would like to introduce our long-term project to you. It's called Public ESO Spectroscopic Survey of Transient Objects. And then in short, PESSTO. The name is actually proposed by Brian Schmidt, although I'm not sure in the time he thought this name, is he hungry or is it dinner time? Yes, so we are PESSTO. And this PESSTO collaboration starts from April 2012. So it's already more than 10 years ago. And then normally we got 99 observational time per 99 per year, yes, and then using the ESO 3.458 meter telescope NTT at La Silla Observatory, and then we mainly use the eFox2 instrument to take spectrum and also images, and also SOFI, which is a capability to the near infrared. However, SOFI just also recently get removed. And then this is our telescope. So we also go La Silla to observe on site. And then back to 2012, our kickoff meeting actually also happened here in Gahin. Was very cold weather, similar time as now. And then we have about 100 members in the beginning, and the project PI is Stephen Smart. And with science board chair is Mark Sullivan. And also we have target and alert team. I will show you more details later, leading by Andrea and also Kate McGuire. And for more transient overview talk, can also look Kate's talk on day one. So we are doing good because then we got 2 years extension. So now we become ePESSTO. And then, so you can see our members are growing, and then now we have more, we have near 200 members in this collaboration. And I think we are doing good, so that's why we have advanced ePESSTO Plus. And then now we get 10 awarded until the end of March 2025. Of course, if SACS is online earlier, and then we will end our mission earlier. And then you can see now we change a bit our science board, and now the PI is Cosmo Insera, and with chair of science board, Joe Anderson, and also myself as the chair of target alert team. And so what we are actually doing is you can see this transient for we found by the sky surveys, and then cause the number of transient get dramatically increases in the past 13, 14 years. So in the early stage, 2005, every day we have one new supernova, new transient, and it also get classified as supernova. And then since 2012, we have 10 stars. So now we are not galaxy targeted search, but one exposure, we can already cross a very huge field of view, and then there are 6 moons can cross in our one exposure sky field of view. So this caused the number discovery of transient objects getting more and more. And now we also have more sky surveys like DTF, Atlas, and then of course the new one go to BlackGen, they will also contribute. And then now we have like more than 20,000 transients got discovered and reported to TNS. So there's one question: how many transients got really take a spectrum, and then we can know which type of them? Do you want to make a guess? Let me ask. How about 90%? Nobody. Okay. People, we are very realistic. 50%. No. Also no. So how much? 10. Okay. Yes. Perfectly. 10%. Yeah. So now the orange line show the number of the object from AT becomes SN. Yeah. Or if they keep 80, there are other things, yes. So, and then it's about only 10% object become supernovae. So our contribution to this 10%. Now I run in for this figure, and then now show you the green line is a transient object become supernova and were classified by PESSTO, ePESSTO, and ePESSTO plus. So in the early phase, we contribute maybe 20% of supernovae, and then in the ePESSTO phase, we contribute 50%. So 50% supernovae were classified by us, and then now we back to 20%. Our classification target number doesn't change too much, but the percentage get lower because we now have a ZTF and SEDN, low resolution spectrum. So they are majority classified supernova, but we provide higher resolution spectrum. So here is our organization overview. We have science board and more than 10 board member in different university and institute. And we also work closely with those all sky surveys like ZTF, and then also Atlas, Pan-STARRS, OGO, and then more now. And we also have quite strong technical support by David Young, and we'll show you his product, Marshall, later. And we also produce the phase 3 data back to ESO, so that everybody can have a high quality data set to use. And then we also have, since we work in big collaboration, and if somebody unhappy with something, you can also find the lost person and then to help our collaboration better. So we are quite efficient follow-up of those transient object with spectroscopy follow-up. I take this object as an example because this object also get highlighted by ESO. So now I'm going to test your eyes by watching this video. Now it's 2021, there is something new. And back to old image taken by Muse, 2014. Can you see there is something new? Now it's your chance. Yes, see some people say yes. So if you have good eye, it's another pointer, try, yes. Can you see cursor? Yes. So this one is a new object. So make here, sorry, make here. Okay, 2021, and then 2014, this object was not there. And then 2021, yes, this object is there. So what is this object? This is when I doing the eyeballing task with Atlas team, and then I found, the left-hand side is the new image, and the center one is the old temperate image, and then the right one, subtracted image. Oh, there is something pop up. And then I was very excited because you can see the whole galaxy have a very cute shape. So then I'm also on duty for the ePESSTO Plus in that night. So I immediately sent this target to tell also ePESSTO. And then in our collaboration, we use this Marshall. So we have every object as a ticket, and then those objects we read from the TNS. So we mainly have all the sky surveys as our feeder, and then we read those alerts every day, and then all input them to our module. So in our module, you can see we will have the name and the coordinate and current brightness and even light curve, and also show you the host information. And because this I screenshot after the real observation, so I show you the other case, the ongoing case. So we have the new object go to module, now still 80 something. And then you can see the coordinates and light curve, host galaxy. So the TAT on duty, they will promote, select this object. They think, this is interesting. We want to do the classification. So the TAT will put the comment for this object, which will also help our observer to pick up this object or just ignore this object as close as possible. But we have a quite nice function, the priority. So the TAT decide, is this target very interesting, become high priority or medium, or it can be like the backup object, like the low priority. So after TAT select target, and then we can leave the comments in the object. Now we back to this cute host galaxy object. So we leave the comments say, and which OB can you use this, and then our observational requirement. So we really have observers on the LSST and then sending from the different institute. And every time when Joe opened now is a call for go to observe, and then almost in one day, then all the run gets volunteered. People really like to go to LSST to observe. So here is our observation control room. So the observer, they will watch the object already get promoted by the TAT. So there are classification targets. Observer need to make a night plan. And we also have follow-up targets. So for the follow-up target, each PI propose their object. So the observer can also fill up to the night plan. And then after observe whole night, they can go to sleep because then we have the other team, support team, will wake up and then do the quick reduction, and then we will release our observational results within 24 hours. So the product we produce is a spectrum, there is a reduced spectrum, and also the astronaut, and then to describe our classification. So the people who are interested can just download the spectrum from the TNS and also Stripe. So this object in the end is a type 2 supernova and then get highlighted by ESO. And even 2 years later, JWST, the first press release, one of the first press release image, they also detect this supernova even 2 years after our discovery. So it's very interesting object. And then here, just to show you one example for our 1 year classification summary, we can find most of our targets are from classified are from Atlas and also ZTF, and also of course Gaia, and then also other like 10 stars, and then also the Go2. So those are the feeder for our module. And then our classification mostly type 1A, but we also have quite some co-cap supernovae and also supernovae and some rare transients. So here are our current science projects in ePESSTO Plus. We have 27 science projects, and then you can, if you have very good eyes, you can read. We are basically include every kind of stellar transients, but not AGNs. And then, so if you are interested in those targets, we are open collaboration. So you can contact the project PI, say, you want to join, and then we can discuss and then to accept your membership join requirement. So after we say we have 27 science projects, now I put it more visual in our transient luminosity phase diagram. And then 15 years ago, this diagram is a bit lonely, only have cold-class supernovae and type 1a supernovae. And then 10 years ago, we know we have something very, very bright, superluminous supernovae. And then PESSTO, we observe like 20 objects in the early time, and then in that time it's quite rare to see the supernovae. So then we collected a large sample and to show the evolution of supernovae and why they are different than type 1c supernovae and what could be their power source. So 7 years ago, of course, we also joined this Kilonova campaign, and then we got one of the earliest spectrum from NTT, and then we think we see the cesium and the tellurium in our ePESSTO spectrum. So this one is the very fast transients, and then afterwards, we also see something unusual because like this one, 2017 ENS, it was hydrogen poor hydrogen poor boronite 1c, but very bright. But in the end, it became type 2N supernova. So the change type supernova. And then now this diagram makes very busy. Here I just highlight objects. Of course, we have more objects in this diagram. I try to make all of them in the diagram, but it's very difficult. So I will keep going on fill out this diagram. But here just want to highlight some objects like those fast transient like the cow. Here is also have our NTT observations. And then we can see this object keep blue for very long time. But the rising time is very short for this object. So it's still a mystery of such fast luminous blue transient. And we also look the object which is faint, and then there can be possibly some stellar merge event called luminous red nova. So we also have a very now hot topic, the tidal disruption event. And we have Jokers here, and then he have a poster and also the talk. So you can please check out. And then, so now this diagram is very busy. And then our contribution is we classify more than 3,700 transient, and then we follow up more than 1,000 objects, and then we published 131 papers from us, and then we also found there are more papers using our PESSTO public spectrum, so which is very nice, and then the community really benefit from our public spectrum. So what we learned from the ePESSTO Plus, which I think is important for the future LSST collaboration. So our transient discovery diagram, now we have 20,000 objects per year, and with LSST online, each year we will have 1 million supernova-like transient get discovered by LSST. So I put this scale is still in Linux just to show you how many alert, how many objects. This is not alert, this is the predict supernova-like transient objects from LSST. So we will have many, many objects. So of course, the thing we cannot do from ePESSTO is we cannot look the interesting object by eyes, like now we are doing. So we will need a broker and have filter, and then we still need TAT to read the object from those filtered results. And then I think we are quite efficient to work together with more than 300 members in our collaboration. So then we use many tools like the Marshall, and then to communicate each other, and also everybody can see what is ongoing observational object, and then what is our observational plan. And then I think our results also have produced quite high impact journal, because we found those unusual objects, and we also collecting large sample to study normal supernovae. And then our model could be extended to a VLT program of ESO-LSST classification and follow up. It's like a very good collaboration and a friendly working environment. So this figure I want to show you in the last, because today also my birthday. I'm turning 40 today. And then, thank you. Okay, thank you. Yeah. And then one of the most enjoyed part of me is to work with our young generation. So here is the TAT team I'm leading, and then from the P103 to P110. And then you can see the TAT who volunteer to say, I want to contribute to ePESSTO. Is in the beginning, we have one student, and then mainly postdoc, and also quite some faculty senior members, they try to contribute. But through the time, you can see the faculty member go down because they have more important thing to do, I don't know. But then postdocs still try to active with us. And then you can see the green line is student. So now the student volunteer TAT job is now they are our manpower to select interesting target, perform them to say I want classification. So I think from this statistics study, I feel it's very inspiring environment, especially for our young generation, because then they feel they are involved, and then they really contribute something, and then they also see the results, see my object based on my science background, why I choose this object, and then it really gets classified and also follow up in the long term. So I think it's it's just to show we are doing well. So finally, now I back to Taiwan. So I want to say we are here, and then we have a Lulin Observatory, which is nearly 3,000 meters high mountain. But we are the only one or two observatory in the whole world without the road the car can arrive. So you are welcome to visit me, and I will bring you to the Lulin Observatory, and then we can work together to see our 1 meter telescope, which is the largest one in Taiwan. And then now we are shipping our 2 meter telescope to Mexico. And then with in-kind contribution, we also joined the LSST. So we hope have first light in 2 years, and hopefully can be a good site to observe LSST alert just after 1 or 2 hours later. So I'm now back to the Taiwan, the Great Lab. And then I also have a new role as the first female faculty in this oldest astronomy institute in Taiwan. We are 30 years, but I'm now take this challenge being the first female faculty there. And I hope thanks to ESO and the ePESSTO, PESSTO, ePESSTO Plus collaboration and colleagues, you are the reason why I now want to take this challenge and back to Taiwan, and then to be a role model, especially for young female students. So thank you very much again for all the opportunities and friends work together for more than 10 years here. Thank you.